Okay, the purpose of this video is just to give you an overview of what's going on in this lab, the enthalpy change for the decomposition of ammonium chloride. So I'm not sure that it's clear in late night labs, what you're doing all these different experiments for. So I wanted to just give you an overview and then talk a little bit about the assignment. So here's what we want to know. We want to know if we were to take some solid ammonium chloride and decompose it into ammonia gas and hydrogen chloride gas, what would be the delta H for this reaction? And so that's the ultimate goal of the experiment. Sometimes, though, it's very difficult to do certain reactions and measure their delta H. So we do it an indirect way. And so the indirect way that we're going to use is a series of calorimetry experiments. And then ultimately what we want to use is Hess's law. So this video is not meant to teach you how to use Hess's law, but rather how the lab is going to relate to Hess's law, and we can eventually find what we're looking for, which is down here. We want to know for this goal equation, what is the enthalpy change? What is the delta H for this particular reaction if we could do it directly? So you'll be learning about Hess's law in Chapter 7, but what I want to do is relate all of this information to the lab. So what we're going to need to find the delta H for our goal equation down here is to take these four reactions and manipulate them, maybe keep it like it is, maybe flip it over, add these four reactions together, cancel what cancels, and then see if we can end up with this as our remaining equation. So what we need, if we're going to utilize Hess's law, is a delta H for each of these four reactions. Reactions 3 and 4 are actually given at the end of the assignment, and their delta H's are also given. So I'm going to try to squeeze those in here, but you'll have those that are given in the lab. So delta H for reaction 3 is negative 34,640 joules per mole, and the delta H for reaction 4 is a negative 75,140 joules per mole. Those are given. We don't have to worry about that. We're just going to utilize them when we use Hess's law. Reactions 1 and 2 are those that we're doing the lab for. So in the experiment, you are actually late night labs refers to this part as experiment 2. In experiment 2, you're going to basically take a solution of hydrochloric acid, add it to a solution of ammonia. The temperature is going to go up. You're going to calculate the delta H for that reaction. Likewise, you're going to do another experiment where you take solid ammonium chloride, drop it in water, the temperature will change. Again, you will calculate the delta H. Late night labs refers to this part of the experiment as experiment 3. So after you do experiment 2 and 3, you'll go through the calculations, you'll have these values, and then you will use them along with reactions 3 and 4 to find the delta H for our goal equation. Alright, so that's the basis of the whole lab. Let's look a little bit at some of the parts of the actual assignment. So again, there's probably could be some improvement here where the lab assignment doesn't match up exactly to the experiment parts, but in the lab assignment, part 1 refers to what's going on in experiment 1. And this is where you take some hot water and add it to cold water, and the whole purpose of this is to find the constant for the calorimeter, which is the actual device that we're using. Alright, so we're going to look for the constant for the calorimeter. That's the whole purpose of experiment 1. So when you do the lab assignment, part 1 is going to walk you through a series of calculations. Again, this is the goal. You're going to find the calorimeter constant, which is then a value that you're going to need to use in the remaining parts of the report. When you get to part 2, again, this is part 2 of the assignment in the actual lab that you'll submit. you're going to, during part 2 of the assignment, determine the delta H for reactions 1 and 2. Okay, again, that's the goal here, right? We're going to try to figure out what is the delta H for this reaction and this reaction. So you're going to go through a series of steps, and at the end of part 2 in the lab, you will know the delta H for this reaction, and you will have worked through the delta H for this reaction. I wanted to make a couple comments here because I think it's a little confusing when you're doing the calculations for this reaction where you did the acid plus ammonia. You basically do these calculations twice. One time you find the delta H per mole of HCl, and the next time you do the calculation you find the delta H per mole of ammonia. But as it turns out, the way the lab is set up, these two values turn out to be the same. So you're actually going to work through the calculation twice, but you just need this number one time, and it's the number that you're going to use right here. So it seems a little bit redundant, and it might be a little bit confusing. So I just wanted to reiterate that, yes, it looks like you're doing the calculation twice because it's asking you to do it twice, but these two are equivalent. Then you'll continue through this part on the assignment and find the delta H for the reaction. All right, so this is actually experiment 2. I know it's so confusing. And this is experiment 3, okay? So by the time you get through working through that, this lab report is a little bit long, but it does walk you through the calculation step by step. By the time you get to the end of this part, you will have all the delta H's that you need, and then you will move on to part 3. Again, this is part 3 of the lab report, and this is where you'll finally be able to use Hess's law, manipulate those reactions 1 through 4, and eventually calculate your delta H. So just try to show your work. You might say something like, okay, I kept reaction 1 like it was, I flipped reaction number 2, I kept 3, I kept 4. Whatever you decide to do, just give some details on how you utilized Hess's law, and then of course report your final delta H value.